Good morning. This is another lecture in Professor Grenfell's Math 12 series, or Statistics at RCC. And today we're beginning a new chapter. Chapter 10 is on correlation and regression. So in Chapter 10, Section 1, we're going to begin with scatter plots and discuss the notion of correlation. In the previous chapters, we talked about two areas of inferential statistics. We talked about forming confidence intervals, and we talked about hypothesis testing. And here we are essentially using these as making a way of, as a way of making a prediction about a certain parameter or parameters within a population. In this subject, we're going to essentially develop a way of determining whether there is a relationship between two or more different numerical or quantitative variables. So, for example, you might want to be interested in the price point that you set for a certain product and the volume in sales that you're going to do, and see if there is a relationship. If you lower the price, will you get more sales, or if you raise the price, will you get less sales? And see, is there a relationship? What is the relationship, if any, between these? And this is the idea of linear correlation. So basically, we're going to look at two things: data on two numerical or quantitative variables. These are the independent variable and the dependent variable. And here, the way of distinguishing these is the independent variable can be controlled, and the dependent variable in the statistical study cannot be controlled. So in the hypothetical study I was kind of referring to, in this scenario where you're interested to see if there is a relationship between the price that you set for a product and the volume of sales, you would say the price, that data, the price in dollars, that is the independent variable, because to a degree in the study you can go and examine different instances where you have set the price at different values, and you have control over that, right? Whereas in this study, the dependent variable, we would say that is the volume in sales, either measured by total units moved or by total revenue, right? That would be the aspect of this that you cannot control, right? So we can set the price at $25, and then we can go and gather the data in terms of how much revenue we generated or how much sales volume we generated, but we can't set that aspect of it. So that's the relation between these two numerical values, and that's what we want to examine. Is we want to see, we assume to a degree that the volume of sales might be linked to and might depend upon the price that we set, but that's the relationship that we're examining here. We're kind of making an assumption that this one, the dependent variable, depends on the independent variable. Right, so one of the first ways that we're going to see how to examine if there is a relation between our numerical values in our data is via a scatter plot. Oh, by the way, this right here says definition. This one, that's always still definition. You thought it had more letters? No, that's all. A scatter plot is the graph of all the ordered pairs that are of the form x comma y, where x is the independent variable and y is the dependent variable. So that's all it is. It's just a graph. We just take every row in our table of data. So our table of data is going to have two values. It's going to have an x value and a y value in it, and we're just going to graph the independent variable on the horizontal axis, the dependent variable on the vertical axis, and in the rectangular coordinate system, we're going to place one point where those two, horizontal and vertical, intersect one another. So we're going to go ahead and do the first example, 10-1. And in this one, we're talking about car rental companies. It says to construct a scatter plot for the data shown for car rental companies in the United States for a recent year. So the first thing that we have to do, the book already did this for us, it gave us this information, but what we need to do, procedurally speaking, is first of all, go ahead and organize our data into a table, kind of like this one here. So I've gone ahead and created a column. I basically just copied theirs, but what I did is, what they did is they created a column for the various different car rental companies, and they just labeled them by A, B, C, D, E, F. And then they listed the number of cars. I'm assuming this is the number of cars they rented, or maybe the number of cars that they have, measured in tens of thousands, and then the revenue that they generated in billions of dollars. So that's the first thing that we need to do. And then we're just going to go ahead and, okay, at this point in time, it is important to determine which is the independent variable and which is the dependent variable. So here, I guess I would say the assumption is that the car company has some control over the number of cars that they have in their fleet or that they rent, right? So that would be the independent variable. We'll use these on the x-axis, and then by default, well, this would be the dependent variable. So let's see. They can go and buy more cars, right? But they can't guarantee that they will get more revenue, right? They're hoping that there is a relation that works that way, but basically that's what we're going to be examining, right? So the first thing that we need to do is we need to be able to make sure that we're processing our data correctly. So we're going to graph on the x-axis the number of cars in 10,000s, and then on the y-axis we're going to graph the y value, the revenue in billions of dollars. All right, so we're going to first draw a coordinate system. Okay, so there are our x and y axes. On the y-axis, that's the vertical axis over here, I'm recording values for our revenue, right? So make sure that we have the appropriate values here so that we'll be able to place all of our data on the y-axis, on the vertical axis. And then similarly over here, we have our number of cars in tens of thousands, and that is our x-axis, the horizontal axis. And similarly, I have labeled values from 5 all the way out to 65 so that we have room for all of those data. Those data range from 8.5 all the way up to 63.0. So here we should have enough room on our horizontal axis to accommodate all of those values. And then the next thing that we're going to do is we're going to just proceed slowly but surely, one by one, to place a a dot, a point on the graph for each one of these pieces of data. So I have a point here at 8.5, comma 1.5. There's a point here representing 13.4 for x. And see right there, that's where 13.4 is. And then 1.4 for y. So, we're just estimating approximately. That's how I'm determining where to place these points. So the next one that I see is 19.1 for the x value. So that takes me right about to here. And then let's see, what is the corresponding y value? We have 2.8. So that would be approximately right about there. And then we just see where those points intersect one another. Right? That would be, how we're working in the rectangular coordinate systems. The x and the y give us the side lengths of the rectangle, and we connect up with the opposite corner over there. And so I've just gone ahead and done that for all 6 of these data points that we have. So each pair of values, each value for the independent variable, each x, and each value for the dependent variable, each y that goes along with that x. Each one of those pairs of values give us one single point in the xy plane. And that is a scatter plot. It's just these 6 points that we've plotted. We put a dot for each one of them. That's another word for graphing it. And they're, as you can see, they're all scattered about here. And then the next thing that we would do with this, once we've constructed a scatter plot, is we'll start to examine it. This gives us a visual means of examining to see if there is, to literally see if there is, or if there appears to be a linear relationship between these variables. So one thing that I neglected to mention is here are just some examples of, last one was bad, but let's just give you some hypothetical scatter plots. So that's one potential scatter plot. And, like I said, I'm just making these up. So here, there is not necessarily any data behind these. These are just hypothetical examples. Yeah, so here are 4 hypothetical basic types of scatter plots. Here we would say this one is exhibiting a positive linear relation between these variables, x and y, the dependent variable and the independent variable. As we increase the independent variable, notice that the dependent variable appears to go up, and it appears that the data in general kind of follow along this straight line path. Right? In this next one, I've gone ahead and labeled them A and B. In this next one, in B, I've written here, this is a negative linear relation. So as we are increasing the independent variable, the dependent variable, notice it decreases. So it's only negative in the sense that this regression line, the line that the data seems to follow, is one that has a negative slope. So here, positive slope means as you're going to the right, you go upward, and negative means as you're going along to the right, you're going downward. So that's all. You see here, this truly is a scatter plot. All of the points are really scattered in C. And so there is no linear relationship. There does not appear to be any kind of cause or effect in terms of what you put in for the the x value versus what you get out for the y value. It's kind of just all over the place. So we would say there's no relationship. And then in D, this is what we call a curvilinear relationship. Just in case you did not know that was a word. Oh yeah. Whoops. kind of my hand kind of slipped there as I was drawing that. But here, a curvilinear relationship sounds like we made that word up, probably because we did. Anyhow, is as it suggests, is neither a straight line that's sloping upward nor a straight line that's sloping downward. It's not a straight line of any type. It is a curving line. It's a more complicated relationship. So as you are increasing your independent variable, at first the dependent variable is increasing, but then in another range that actually causes a decrease. So curvilinear, more complicated relationship there. So still useful, but for our purposes, we're not going to really get into that. We're only going to be concentrating on A and B. If our picture does not look like either A or B after we have constructed our scatter plot, if it's one of these where it looks like there is no linear relationship, either no relationship whatsoever, or if there maybe is a relationship, but it's not a linear relationship. If it is like this, if it is curvilinear, then we're just going to basically stop at that point. We're going to say, well, there's no relationship between these. There's no linear relationship. They are not correlated linearly. And we would stop there. If there is a linear relationship, then in later subsequent sections of this chapter, we will talk about how to proceed onward from there and more fully describe that relationship that is there, and to test how strong of a relationship it is, and then use it to make predictions about one value influencing the other. But that is what is to come in the rest of chapter 10. Stay tuned.